Howdy y'all, this is Kevin. This is question 8 for the physics. Sorry if I feel not a little well. I sound not a little well because I feel not a little well. But either way, let's look at this. So I drew this diagram up here. Important thing to note, the shell, this is a conducting sphere, and you have to know that the inside's not conducting. They didn't tell you that, but the problem works out that way. So for A, we want to know the electric field when the radius equals 0. So this means it's in the dead center of the sphere. If it's in the dead center, you might recall this means there is no electric field. That is the case for non-conducting. If it's in the dead center, there is no electric field because the electric field perfectly cancels out because it's in the center. And if it's a conducting field, as long as it's inside of it, it also cancels out. So, yeah, so for A, it's 0. Simple enough. If your R equals 0 at least. You might not have the same numbers. Okay, so for B and C, B and C are very similar because B and C both lie inside the sphere. B, for me, I think it's R equals A over 2, and C equals R equals A. So it's inside the sphere, so they actually use the exact same way of tackling it. So if you remember Gauss's law for a sphere, you have E equals charge. I think it's radius 4 pi. Oh no, the radius goes on the bottom. 4 pi r squared. And then I don't remember what this constant is called. But all you need to know is that this constant equals 8.85 times by 10 to the negative 12, I think. You should have that on your sheet. So let's look at, in my opinion, this is how I did it. I know there's a sheet from someone sent that has all the work, but in my opinion, it's easier to start with C. C is looking at R equals A. So our sphere that we're working at is actually just the entire sphere itself. And we know the charge of the entire sphere, and we know the radius of the entire sphere, of the inside sphere. So for me, you just plug it in. For me, my charge of the inside sphere was 7.75 femocoulombs, which is 10 to the negative 15 coulombs. To know that, I have to look that up. Divided by 4 pi r squared. For me, r is 0.039 meters because you have to turn it into meters. It gives you in centimeters. And then e to whatever the hell that is 8.85 times by 10 to the negative 12. And this would give you your answer. For C. So the numbers for you that will be different is this. This is going to be your Q1. And this is going to be your the distance for A. Now for B, so that's the answer to C. The reason why I did C first is because, well, for B, your radius is a half. So you're using a very similar formula. This is for C. This is for B. So your radius is a half, but your Q is not the same because since your radius is halved, your sphere that you're working with is going to be smaller. If you remember the area of sphere for some constant, who cares? But there is an r cubed. And since your r is halved, your volume would be 1/8 the size. Your volume would be 1/8 the size. And if your volume is 1/8 the size in a non-conducting sphere, this means your charge is 1/8. So in comparison to C, for B, the charge is 1/8. But then the radius is 1/2. And take a look at this. What's 1/2 radius squared? That just equals 1/4 radius squared. And this 1/8 I'm ignoring this 4 pi and this weird number because it's a constant. I don't give a shit. So either way, if you take a look at this, you realize that the ratio between what C and B is that B is 1/2 of C. And whatever the hell you have for B and C, as long as it's inside the sphere, this applies. So B will be 1/2 of whatever C is if you have the same ratio as I do. If not, then well, you have to plug it into here. So like if you had 1/4 the radius, you have to plug in 1/4 here and 1/4 for your radius for the volume. But I think we have all the same for that part. So either way, moving on, let's look at D. Okay, so for D, we're looking at 1.5a. So I'm going to stand on this side. I don't know if you can see me. So for 1.5a, it's actually around here for D. So now, we could treat this almost exactly like gravity. You might be thinking, oh, do I need to consider this sphere out here? No, you don't, because it's everywhere. It's pulling on it at the exact same in every direction. So this sphere, not the sphere, this shell on the outside has literally no impact. So how I dealt with this is I thought of it kind of like gravity. We have a point charge, because you can do that just like in gravity. You could pretend all the mass is exactly at the center. And we're going to do the exact same thing. We're going to pretend all the charge is exactly at the center. So then we use the Coulomb's constant, the charge, over the distance squared. This equals the electric field at that point. This is exactly the same thing as the force by gravity equals the gravitational constant times by the mass by the distance squared. It doesn't matter what the hell this on the outside is or what that is. It just doesn't matter. So you should just plug this in. K, which equals, I think it's 9 times 10 to the 9. And then Q, whatever your Q is, mine is 7.75 times 10 to the negative 15 coulombs. The distance is 1.5. A, which for me is 0.039 meters times by 1.5 squared. And then yeah, you plug and chug. And that gives you, this is question D. For E, you might already know this. It's asking us the charge inside of here. And we're inside of a shell. We're in the middle of a shell that is conducting. No, we're not in the middle, we're inside of it. And if you remember, if you're not on the rim, it's 0 for a shell that's conducting. Not for a non-conducting, but for conducting, as long as you're inside, it's 0. So E, it's 0. Let me remind myself what F is. So F is asking, now F is asking 3.5a. So for me, F is on the outside right here. And it's asking, so this is F right here. And it's asking for the electric field out here. Well, we just take the total charges because it's being pulled by this and that. And if your question is the same as mine, the charge of this and the charge of this cancel out. They're exact opposites of each other. So the distance doesn't matter because it's 0 divided by whatever. So F should be 0 as well if your point is outside of the whole thing. The teacher talked about that too, actually. G, I actually briefly mentioned how to solve this. G is saying, what if the charge is on the exact ring? What is the charge, not the electric field? Well, this thing is conducting, so let's think about that. It has a negative charge, and this is a positive. So all the charge should go towards the positive. So all the charge should be on the inside ring, and there should be no charge on the outside ring. So this should be whatever your number is, which means -7 whatever charge, and then the outside should be 0. And yeah.